When solving a fractional or rational equation, I'm looking to multiply both sides by the least common multiple of each of the denominators. So that would just be a minus 3 and a plus 2 in this case. I'm also going to go ahead and add the opposite, and then I'm going to go ahead and multiply a minus 3 and a plus 2 by the first term, then the a minus 3 and the a plus 2 by the second term, and lastly the a minus 3 and the a plus 2 by the last term. Now, when I go ahead to do this, terms in the numerator can cancel with terms in the denominator. So I'm just left with 3 times the a plus 2, and I'm left with a minus 3 times negative 1, and on the right hand side, just 0, because when you multiply by 0, you'll always get a 0. Distributing, I have 3a plus 6, and double distributing, I'll have it's not double distributing, I'm just distributing a negative 1. Okay, so let me fix that. So that means each of those terms is just being multiplied by a negative 1, so I'll have negative a plus 3. So 3a plus the negative a would be 2a, and 6 plus 3 is 9. So that means 2a is equal to negative 9, or a is equal to negative 9 divided by 2. I should check to see if that would give us a result of 0 in either of the denominators, and it doesn't. So those are the two answers. At first glance, this doesn't appear to be a problem involving logarithms, but we can't change these bases so that they have the same base. Instead, what we're going to do is take the log of both sides. And remember, one of our properties of logarithms allows us to bring exponents out front. So this becomes 3x log of 2 equals log of 7. And I'm going to divide by this and this to get the x by itself. So I'm dividing both sides by 3 times log of 2. So x is log of 7 divided by 3 times log of 2. And that's a fine answer. In fact, that's the exact answer. But they ask us to round our answer to the nearest tenth. That means we're going to go ahead and type this in our calculator and round to the nearest tenth. The result would be about equal to 0.9. The issue that I have with this trigonometric equation is that the angles are different angles. And so I'm going to go ahead and use a trigonometric substitution. I'm going to replace sine of 2 theta with 2 sine theta cosine theta. Now, the good news is we got rid of the two different angles. We had a 2 theta and a theta in the same problem. Now this problem is expressed only in terms of one angle. The bad news is we still have sine and cosine in this problem, but this problem, there's a little trick. What we can do is we can subtract that sine on the right-hand side back over. Now there's a GCF of sine, and I can factor the sine out, and when I divide this term by sine, I'm left with 2 cosine, and when I divide this term by sine, I'm left with negative 1, and the zero product rule allows me to set each of these equal to 0, so sine of theta is equal to 0, or 2 cosine theta minus 1 is equal to 0. Sine of theta is equal to 0 at 0 degrees and 180 degrees. I was just checking to see if they wanted the answers in terms of radians or degrees. It says between 0 and 360, including 360. So 0, 180, and 360 would all be answers. And with this other equation, I can add 1 to both sides and divide by 2 to get cosine of theta is equal to 1/2. Now, we know that cosine is equal to 1/2 at 60 degrees. And cosine is also positive in quadrant 4, and 360 minus 60 would be 300 degrees. So the answers are 0, 180, 360, 60, and 300 degrees. When talking about domain, we mean how far left does this function go and how far to the right does it go. So this function has values as far left as -5 and as far right as +8. So the domain would be from -5 to +8. For the range, when we talk about range, we're thinking how low does it go, how high does it go. This function goes as low as this point here, which has a y-coordinate of -3, and as high as this point, which has a y-coordinate of 2. So we would say that the range is from -3 to +2. So I have a force of 85 and 25. Up here is the other 85, and here we have the other 25. The resultant is drawn in, and we're told that the angle between the two forces is 55. They're asking us to find the magnitude or the length of this resultant. Now this 55-degree angle is not part of this triangle, and it's not part of this triangle. Rather, it's the angle, this entire angle between these two sides. So the only reason they're telling us this is so that we can figure out this angle here, because a property of parallelograms is that this angle and this angle, called consecutive angles, are supplementary. So 180 minus 55 is 125. This angle is 125 degrees, and this is a classic setup where we have two sides in the included angle. That's a law of cosine's problem. The law of cosine's formula: a squared equals b squared plus c squared minus 2bc. Cosine of a is given on the reference sheet. And remember that these are the two sides that enclose the angle. So in this problem, I'm going to find the magnitude of the resultant by squaring 25, squaring 85, and subtracting 2 times 25 times 85 times the cosine of 125 degrees. Now I typed that entire expression into my calculator. The result was 10,287.7. That seems like a pretty large number compared to 25 and 85. And it is, and that's because it's not the answer. Our answer will be found by solving for a, so we need to take the square root of that 10,287.7. To the nearest hundredth, the answer would be 101.43. So that means that we know the length of this side. I'm going to redraw this information on the parallelogram. And the next part of the question is asking us to find the measure to the nearest degree of the angle formed between the resultant and the larger force. That would be this angle, and this would be the side across from that angle. And so when I have all three sides, that's again an example of a problem where I need to use the law of cosines. It's important where I put the sides in this problem. And this is the side across from the angle that I'm trying to find. So that's the side that goes in for A. The other sides go in for B and C. Okay, so I'm going to be careful that I will square this value and this value and add them together and then subtract over to the left. And now I'll subtract the 17,513 from both sides. Next, I'll divide both sides by the negative 17,243.1. A negative divided by a negative is a positive, so I'll change both of those to positive. And I am trying to find the angle, and so I'm going to use inverse cosine of this ratio to find angle A. The directions call for us to round this to the nearest degree, so 12 degrees.